So we had one gauge parameter for Weyl transformation, for Weyl symmetry. Whether we call it capital omega or we call it, so this is a function of sigma alpha, this is also a function of sigma alpha. So we have one gauge parameter, either capital omega or small omega. Okay, both are functions of sigma alpha. This or this. Okay, this or this. So, and these are local. The gauge parameter is local. Why? It depends on the local coordinates, sigma alpha, which are the worldsheet coordinates. Okay, and we had this zeta gamma or zeta alpha or whatever you call it. This is also a function of sigma alpha. So we had two parameters, zeta 0 and zeta 1. So we have altogether three gauge degrees of freedom. So we have three gauge degrees of freedom, one corresponding to omega or omega and two corresponding to zeta. And this is what we have made use of in fixing up H alpha beta or whatever it was, H alpha beta. Then if it is to be taken like that, then this is also equal to H alpha. Okay, so it's a flat metric. And making use of this here, we reduce this xn to be equal to del. So this is your conformally gauge fixed Fourier coefficient, right? And this is what we would be considering there in connection with the RNS superstrings when we add this. So I think now we could easily go into the, we could skip many more things, but let me tell you how do we introduce the light front coordinates. Okay, and then you could write down everything in terms of the light front coordinates if you wanted. Okay, if you wish. So or x plus minus, which we may or may not use, the convention that is very much in use is this, and the other one which we would be using more often is sigma alpha is tau and sigma, or sigma 0, sigma 1. Here we define sigma plus minus as sigma 0 plus minus. So this we are doing without a factor of square root of 2. Okay, but we will watch out for this. Okay, so it is this, and this is equal to tau plus minus sigma, and therefore I could write down del plus is del over del sigma plus, which is del tau del sigma plus and this would be 1/2 del tau plus del sigma, and this would be del sigma minus, this would be 1/2 del tau minus del sigma plus. So we conclude here, this is tau plus minus sigma and del plus minus h 1/2 del tau plus minus del sigma. Okay. Now, just as an exercise, you could write down the major ds square in terms of this. So if you write down this is d sigma mu, d sigma nu, beta mu nu. You could write it as minus del tau square plus or minus d tau square plus d sigma square. This would be in the instant form. Okay? And in the light form, this would be the same expression, but this would be minus d sigma plus d sigma minus, and if you were to write d2 sigma d tau d sigma, and if you express it in the light form. So actually what happens in the instant form, your eta alpha beta is minus 1 0 plus 1, whereas in the light form eta alpha beta would be 0 minus 1/2 0, and this would be 0 minus 2 0. This actually 1/2 and 2, this comes about because in our definition we have, had we taken this divided by square root of 2, then this would have been just minus 1 minus 1 minus 1 minus 1. Is that all right? If we take this divided by square root of 2, then this factor of 2 disappears from all these places. It remains minus 1 minus 1 minus 1 minus 1. Okay? So, wherever one takes, one has to take care of this. Whether we are, and it comes from here, okay, from the very first definition, if we have it divided by square root of 2 or not. Okay, so let's stick to this because most of the literature they are using this. Okay, so let us use the conventional, little more conventional thing. But let me tell you the difference of writing down the when you take some, for example, this is just some arbitrary x alpha, eta alpha, beta, x beta, and this. So what happens in the if I want to write plus, then this is eta plus beta x beta. This would be eta plus, now beta h plus eta plus is fixed there. So beta takes two values, plus and minus. So minus x minus. Now what was my eta here for light front? This was 0 minus 2 0. So g plus plus is 0. So this is 0. This h plus minus, this is minus 2. So this is equal to minus 2 x minus. So whenever you work with instant for light front, after this one must work out what is your conversion. So x plus is minus 2 x minus, then x minus would be this. Okay, you can prove it, the other one. Just using the raising and lowering operator. Now just let us have a look into the other one. So x, for example, 0 with eta alpha beta x beta, what will happen here? This would be eta alpha beta x beta. This would be eta, now in the instant form. Okay, if I write 0, then I am writing in the instant form. So 0, now beta will take two values, 0 and 1. So 0 0 x0 plus eta 0 1 x 1. Okay, now here I have eta alpha beta equal to eta alpha beta equal to minus 1 0 0 1. So this is minus 1 and this is 0. So what I have is minus x0. Okay, so here like I had this with this definition of mine, now x0 would be minus x0, but if you calculate x1, this will come out to be plus 1. Okay, with this convention of